Hello everyone, this is Jambagi welcoming you all for 9th standard online classes. Dear students, in the previous period we solved some problems regarding SI abbreviations are concerned. Now in today's lecture we are learning rules of writing SI units, advantages of SI units, and measurement of length, mass, and time in brief. Dear students, let us learn rules of writing SI units. To write International System of Units, some rules need to be followed. So they are as follows. Number one, symbols and prefixes are same. Symbols and prefixes are same irrespective of all languages. In the world, we are having so many languages. Symbols and prefixes are same irrespective of all languages. In the world, we are using so many languages. Irrespective of all languages, symbols and prefixes. So symbols and prefixes remain same. For length, we are measuring that by meter. Okay, we are measuring the length in meter. So meter will be the unit. It is abbreviated as M, meter. Okay, here the M will be the symbol, M will be the symbol, and meter will be the prefix. Prefix will be meter. Okay, so irrespective of all languages used in the world, meter and M remain same irrespective of all languages being used in the world. Now the second one, always use 0 before the decimal mark when the value is less than 1. When the values are less than 1, you have to use 0 before the decimal mark. As an example here, we are having 0.6. Okay, 0.6 is less than 1. So for the rule is saying that you have to write like this only. You have to use 0 before the decimal mark. You have to use the 0 before the decimal mark. This is the right method, and you cannot write like this 0.6 or anything like that. That is a wrong method. So you have to follow, always use 0 before the decimal mark. Before the decimal mark, you use 0 if the value is less than 1. Let us move to the next rule. No spacing is allowed between prefix and unit. No space is allowed between prefix and unit. Let us take the example of measurement of mass, that is kilogram. So kilogram should be written like this. So no spacing allowed between K and G. K will be the prefix, G will be the unit. Therefore, no spacing is allowed in between. Not written like this. No space should be allowed in between. This is the wrong method and this will be the correct method. So take one more example here. Megahertz, the frequency of anything. Megahertz, say radio wave as an example. No spacing is allowed between M and HZ. M and HZ will be written like this, not written separately like this. No gap is allowed between a prefix and a unit. I hope you are following this rule clear. Next one, never use full points or any other punctuation marks after this symbol. After this symbol, say for example, take the Newton, the measurement or the unit used for force. Okay, so you must not write full point or commas or any other punctuation marks like this. You must not write any punctuation marks like full point, comma, this, so on. You must not write like this. Okay, never use a full point after the symbol. If you are using the symbol Newton, you should be kept like this only. This is the right method. I hope you are following this rule as well. Now, next rule will be symbols of units cannot be pluralized. Symbols of units cannot be pluralized. Means if there is a length of 100 meter, you have to say it as 100 meter only. You have to say 100 meter only, not 100 meters. So in English, we are using so many. If a boy is there, you are saying a boy. If there are two boys, then you say two boys. You are making the plural form, isn't it? So you must not do in this case here. Symbols, for the symbols of unit, it cannot be pluralized. For a symbol of units, you have to take care, they cannot be pluralized. If it is 100 meter, 100 is having the things more, the value more than 1, means it has the probability of getting pluralized. But take care that even though it becomes 1000 and 10,000, it doesn't matter. It is only written and pronounced like 1000 meter only, not meters. Okay, 100 meter only, not 100 meters. I hope you are following this rule. Symbols of units cannot be pluralized. Okay, for your understanding, let me give one more example here. There is a voltage of 10,000. Okay, there is a voltage of 10,000. You have to say it is equal to 10,000 volt only, not 10,000 volts. You must not be pluralized. Units and symbols, or say symbols of units, cannot be pluralized. Okay, you must not say volts, you say just volt. Okay, you write like this only. I hope you are following this rule. Next rule, a unit named after a scientist. A unit is named after a scientist. Let us bring joule here. Again in English, anything written, if it is a name, there is a tendency of writing capital letters. There is a tendency of writing capital letters. For unit case, joule is the name of the scientist. A unit named after a scientist must not write with a capital letter. Must not write with a capital letter when the name is completely written. When the name is completely written, you must not use capital letters at all. Okay, so this is the wrong method while using the units. So if you write the complete name, you keep it as it is, joule, small j, small o, u, l, e. You write like this only. Okay, a unit named after a scientist must not start with a capital letter when the complete name is written. Complete name is written, then you must not start with the capital letter. And capital letter is used when the name is not written completely. When the name is not written completely, you can use capital J instead of Joule, joule. Okay, you have to say either J, capital J, or if you are writing completely, you written in small letters only. I hope you are following this rule. Now, seventh one, the units other than those names can be written in small letters. The units other than the scientist names you have to write in small letters only. For example, length again, meter. It is written in meter only, small letters. So similarly, kilometer. Okay, kilogram. I hope you are getting this well. So any unit written other than the scientist names, it should be maintained in small letters only all the time. Okay. Similarly, second here you can quote. Okay, will be never use compound prefixes. Never use compound prefixes. For example, you take kilogram here again. So kilogram is written. So never use compound prefix like this. I'm using one more thing. M, that is mega kilogram. Mega kilogram cannot be written like this. So don't try to use what? Mega, kilo simultaneously. These are called compound prefixes. So M will be the one prefix, K will be another. K is equal to 1000, M is equal to 10 to the power 6. Okay. So don't try to mix the compound prefix. Better instead of writing mega kilohertz, kilogram, mega kilogram, better you say 10 to the power 6 kg. This will be the correct method. So never try to use compound prefixes. If at all you are using, make use of their 10 to the powers. That will be better for you. I hope you followed all the rules which I discussed. Dear students, let us move to the next part, that is advantages of system of SI units. Let us learn the advantages of system of SI units. First one, it is a coherent system of units. It is the coherent system of units. Coherent system of units means what? All derived units can be obtained by multiplying or dividing certain set of fundamental units. By using certain set of fundamental units, all derived units can be obtained by multiplying or dividing. Okay, by multiplying or dividing set of fundamental units, all derived units can be obtained, and hence it is said to be coherent system of units. Second one, it is rational system of units. Rational system of units means what? It uses only one unit. It uses only one unit for a given physical quantity. Let us take the example here. Joule is the SI unit of energy. We are having so many forms of energies like sound, heat, light, electricity, so on. There are various forms of energies are there. Even though we are having different forms of energy, joule is taken as its SI unit. As SI unit, we are writing joule for various forms of energy. That is why it is called a rational system of units, which means it uses only one unit for a given physical quantity. For a given physical quantity, we are using only one unit. So we are having so many forms of energy. Even though we are having so many forms of energy, SI unit will be always taken as joule, and hence it is called as rational system of units. Third one, it is a metric system of units. It is a metric system of units. All multiples and fractions can be expressed in terms of 10 and its powers. So we are expressing multiples and fractions in terms of 10 and its powers. So playing with 10, as I'm already said, that it is considered to be as all multiples and fractions can be expressed in the power of or in terms of 10 and its powers. That's why it is metric system of units. Fourth one, system of SI units is closely related to CGS system. System of SI units is closely related to CGS, centimeter, gram, second system, and hence it can be easily exchanged. You can convert from international system of unit to CGS system to international system, because they are closely related. Now fifth one, this system is accepted internationally. Worldwide it is accepted. This system is accepted internationally. So these are all the advantages of international system of units. I hope you followed all these points. Dear students, let us move to the next part, that is measuring of length, mass and time. So first we need to understand the measurement of length. Length is the distance between any 2 points in a space. We already know that from our previous understandings. Length is the distance between any 2 points in the space. Any 2 points in the space is nothing but length. Okay, length is the distance between any 2 points. Say in this case AB is nothing but length. Lengths can be measured either directly or indirectly. So lengths can be measured either directly by direct measurement or by indirect measurement. There are two ways in which lengths can be measured. The direct method involves, so as I said that lengths can be measured directly. So the direct method involves length of chosen standard. Okay, the direct method involves the length of chosen standard, that is in the order of 10 to the power minus 5 meter to 10 to the power 2 meter. So between these two ranges, direct method can be done using instruments as such spirometers, screw gauges, vernier calipers, meter scales, so on. So you can measure the length directly between these two ranges, 10 to the power minus 5 meter to 10 to the power plus 2 meter. So 10 to the power minus 5 meter, for that direct measurement spirometers are used, and again it is coming to 10 to the power minus 3 like that. So screw gauges are preferred. If it is of 10 to the power minus 2 and minus 1 like that, we are using vernier calipers. For 10 to the power 1 and 10 to the power 2 meters, we are using meter scales. Okay, so direct method involves the chosen standard, length of chosen standard, that is in the order of 10 to the power minus 5 meter to 10 to the power plus 2 meter using such instruments. The indirect method involves length of atomic and astronomical standards. So indirect method involves the length of atomic and astronomical standards by measuring the size of molecule, parallax methods, so on. So if any length or any method which is less than 10 to the power minus 5, we call it as atomic standards. So atomic standards, you cannot measure directly here because it is such a lower scale. You cannot go using the direct method or direct principle, but you can use indirect method by measuring the size of liquid molecule. By measuring the liquid molecule of sophisticated technique, you can measure the length of the or size of the liquid molecule. That is indirect way. Even you are not measuring directly here, you are taking the indirect path to reach the smaller scales. Similarly, you can move to the astronomical standards. They are of very high scales. You cannot take the length for astronomical standards. So parallax methods, so many other, say example gravitational methods, all they are preferred for indirect method. So for measuring the length which is less than this value of 10 to the power minus 5 meter, we are using the indirect approach by measuring the size of liquid molecules as such. And if the length is more than 10 to the power 2 meter, we are using parallax methods, and again we are moving to the astronomical standards. Well, okay, of the objects from smaller scale to higher scales, length is varying in a very wide range. That is in the order of atomic to astronomical ranges. See, atomic standards of 10 to the power minus 16 meter, 10 to the power minus 16 meter, that is the radius of the electron. Radius of electron, which is very much smaller, that is in the order of 10 to the power minus 16 meter. And we are having the astronomical range over 10 to the power 26 meter, that is the size of observable universe. The size of the length of the observable universe is in the order 10 to the power 26 meter. So one is 10 to the power minus 16 meter, means 0.00 up to 16 meter, and on the other hand we are having 10 to the power 26, means we are having the 10 which is of 26 times. Okay, so this is the length over a very wide range. So length of the objects can be varied over very wide range from 10 to the power minus 16 meter, that is radius of electron, and 10 to the power 26 meter, that is the size or length of observable universe. Other practical units of length. We are using some other practical units of length. So first one in this case will be Fermi. 1 Fermi, remember all these practical units are only preferred for length. Mark my words very much carefully, dear students, that please take a note. These units are only being preferred for length, not for any other physical quantities. It is only meant to be for length. That's why I mentioned other practical units of length. Okay, so first one will be 1 Fermi. 1 Fermi is equal to 1 F. It is written as 1 F, 1 small f. Okay, which is equal to 10 to the 1 into 10 to the power 15 meter. If the length is of this much, 1 into 10 to the power minus 15 meter, then we consider it as 1 Fermi. So 1 Fermi is equal to 1 into 10 to the power minus 15 meter. Next one will be 1 angstrom. 1 angstrom is written 1 a to the power 0. That is 1 a to the power 0 is nothing but 1 angstrom, which is equal to the value 1 into 10 to the power minus 10 meter. 1 into 10 to the power minus 10 meter is equal to 1 angstrom or 1 angstrom unit. Okay. Next one, 1 micron. 1 micron means 1 micrometer. 1 micrometer is taken as 1 micron, which is equal to 1 into 10 to the power minus 6 meter. 1 into 10 to the power minus 6 meter is equal to 1 micron. So 1 micron is equal to this much value. So these are all of the scales of lower standards. Lower standards. Now for higher standards, we are also using some other units of length. 1 astronomical unit. 1 astronomical unit is equal to 1.5 into 10 to the power 8 kilometer. 1 into 10 to the power 8 kilometer is equal to 1 astronomical unit. So 1 astronomical unit is equal to 1.5 into 10 to the power 8 kilometer. Similarly, 1 LY. 1 LY is light year. 1 light year is equal to 9.46 into 10 to the power 12 kilometer. 9.46 into 10 to the power 12 kilometer is equal to 1 light year. Next, 1 PC. It is taken as 1 parsecond. 1 parsecond. It is abbreviated as a parallax or parallaxial second. That is shortened as parsec. 1 parsec is equal to 3.1 into 10 to the power 13 kilometer. 1 parsec is equal to 3.1 into 10 to the power 13 kilometer. So these are all the other practical units used for measurement of length. Let us move to the measurement of mass. Mass is the amount of matter contained in a body. Mass can be defined as it is the amount of matter contained in a body. So whatever the quantity of matter or the amount of matter is there inside the body is taken as mass. Mass can be measured by using physical balance. By using physical balance, you can measure the mass. In the atomic level, mass can be determined by spectrographs. The spectrograph is the device which is used to measure the mass in the atomic standards or atomic level. And in the astronomical scale or level, it can be determined by gravitational methods. Using gravitational methods, we are using the mass of the heavy or heavenly bodies. They are celestial bodies like sun, star, any other stars or any other celestial objects. Is varied over a range. Mass is varied over a range for the different objects in the order of atomic scale. Again, we are making the divisions from atomic standard to the astronomical standards. For atomic standard, mass is from 10 to the power minus 30 to the power minus 30 kilogram, which will be the mass of electron, which is very, very much small. We are having 0.30 times 0 again, then 1. That will be the mass of electron. You cannot measure directly. Again, it is the indirect method. So 10 to the power minus 30 kg will be the mass of electron. It is in the lower level. And on the astronomical standards, that is of 10 to the power 55 kilogram. 10 to the power 55 kilogram will be the mass of observed universe or observable universe. Observable universe has the mass of 10 to the power 55 kilogram. Next will be the other practical units of length. Other practical units of length. 1 AMU. 1 AMU is nothing but 1 atomic mass unit. 1 atomic mass unit is also the unit of mass which is equal to 1.66 into 10 to the power minus 27 kg. 10 to the power minus 27 kg. 1.66 into 10 to the power minus 27 kg is equal to 1 atomic mass unit. Next one, that will be 1 metric ton. 1 metric ton is equal to 10 to the power 3 kg. 10 to the power 1 into 10 to the power 3 kg is equal to 1 metric ton, or simply you can call it as ton. 1 ton is equal to 1000 kg or 1 into 10 to the power 3 kg. Next one will be the 1 CSL. CSL is the shortened form of Chandrasekhar's limit. Chandrasekhar's limit is equal to 1 CSL. That is equal to the value of 1.4 times mass of the sun. Any object which is equal to or which is more than 1.4 of that mass of sun or solar mass, that is taken as 1 CSL, 1 Chandrasekhar's limit. This is the unit named after the Indo-American scientist Chandrasekhar Subramaniam Chandrasekhar. Then the unit named after him. Next part, that will be measurement of time. Measurement of time. Time is a measure between two events or what the clock reads. Remember the definition of time, which will be very complicated thing in physics. Anyway, time is the measure between two events or the what clock reads. Whatever the clock reading, that will be the time, or it is the measure between two events. We read time as a time interval. We are saying time as time intervals or interval of time. Time interval or interval of time, we are reading it as generally. The time interval between different phenomena vary over wide range. Yet again, the time interval between different phenomena varied over very wide range. That is in the order of, again in the atomic standards, that is of 10 to the power minus 34 second. So time is in the order of 10 to the power minus 34 second. That will be the lifespan of unstable particle. The lifespan of unstable particle, it is in the order of 10 to the power minus 34 second to 10 to the power 18 second. 10 to the power plus 18 second, that is the average lifespan of a star. So time is also varying over the wide range of 10 to the power minus 34 second to the 10 to the power 18 second. I hope you understood measurement of length, measurement of mass and measurement of time. This ends the topic of measurement. I hope you understood all the points discussed in this chapter. If you are having any doubt, make use of my WhatsApp number to form the questions.